So today in this video we are going to understand the equations of motion. There are three types of equations of motion we have. First of all, let me introduce the equations. The first equation is V equal to U plus AT. The second equation is S equal to UT plus half A T square. And the third equation is V square equal to U square plus 2AS. And even some books this is written as V square minus U square equal to 2AS. Nothing is different, just the U has transferred into the other side and they became minus. Otherwise these both are same. So these three equations of motions we have, and we have to derive this by graphical method. So these three equations have different kinds of symbols. Variables we have taken the English alphabets, just like V, U, okay, T, S, etc., and also A we have. So these symbols we have used, and these all have different meanings. Just like U is known as initial velocity, okay, V is known as final velocity, T is known as a time, all you know, S is a traveled distance, and the A is well known acceleration. Okay, this is the usual meaning of different symbols we have used here, or the letters we have used here. So one by one, in three different videos, we are going to understand how to derive all three equations. But before that, we need to understand the graph. One single graph which actually going to define all these three equations of motions. Okay, so let me introduce first the graph here. So we need to prove that V equal to U plus AT. For that we will take the area between the axes X and Y. You know that the horizontal axis is always X and the vertical is Y. On the horizontal axis we always show the time, okay, and the vertical axis we will show the velocity. Okay, so whatever the time we will take here on the X axis represented by the T here. Okay, suppose I am taking up to here or here or here, it will always known as a T. Okay, we will take the value T like that. Okay, so on the Y axis, since we will going to take the V, because we need the acceleration, so we will take under the VT graph, okay, the velocity time graph. On the Y axis we are going to represent the velocities. Okay, velocities I'm saying just because we will take two types of velocity, U and V, initial velocity and the final velocity. Okay, so starting from the 0 only, there is the origin where the X is also 0 and Y is also 0. There is origin, okay, now that I'm taking about. So now from here, when you start your motion, okay, initially you will get the initial velocity. Suppose that is the time, by the time T we are going up to this much value. This is the A point here. Okay, this is the A point, and till that we will take the value as U, the initial velocity. And after some time we are reaching at the B position here. Okay, where is the final position for us, and the value up to B from the O will be V totally. Okay, from the O, whatever the measurement you will take, it's only from the origin only. So origin to A become U and origin to B become V. So we can say that AB, between the A and between the B, the measurement will be V minus U. Okay, I hope it's visible to all of you. I'm just zooming it out so you can easily see that. So it is V minus U, since because from O to B we have taken V and O to A only we have taken U. That's why the remaining portion, the AB, will be the subtraction of V minus U we have written over there. Now we are going to take one slope between the AB. Okay, like this. This slope will represent the acceleration between the V minus U, because we know the acceleration is equal to delta V upon T, which is equal to V minus U, okay, upon T. Okay, so right now we will write like that only. This is acceleration. Again we will take a parallel line and then we will complete this figure like that. Okay, so we can rename this all things. Okay, this is O, then A, then B, followed by C, D, and this is point E we will take. Okay, that much we have taken as a time. We will take T, and this line also parallel to this line, we can write, say this is T also. Okay, and this line is parallel to this line, we can write V minus U for it. Am I clear? So in this triangle, if we exit out, okay, this triangle, if we're going to highlight, so we will get this triangle like that. This is the angle theta, this angle the theta we have the same. The naming we will take so that we can easily configure it. This is A, this is C, and this is D. I hope now it is very clear to all of you that which triangle I'm talking about. A, C, D here. Same we have written there, A, C, D. The angle is formed between the C and D is here. A, we have a theta. So we can write the triangle name as CAD. Okay, because A have the angle between them. Okay. So the slope was the acceleration between V minus U. So we can write the tan theta. For slope, we always represent the tan theta, which will be required for the acceleration. Okay, A equal to tan theta, which is equal to, the formula of tan theta is what? Perpendicular upon base. Okay, for P stand for perpendicular, B stand for the base. So here the CD is the perpendicular and AD is the base. Okay, so we can write A equal to CD upon AD. CD is what? Same this one, V minus U. V minus U. We can write A equal to V minus U upon, what was the AD here? AD was, you can see, this is the time axis, parallel to time axis. We can write this is T. Okay, so now finally we get the configuration of the equation, and we can write now like that. We just do the cross multiplication, we will found that V minus U equal to AT. Okay, now we have to replace this U on another side, right hand side. We'll get V equal to U plus AT. Okay, this is the final formula or the equation we can get for the first. Okay, the first equation now we have derived.